Hi, I'm a neuroscientist, and I study how the brain makes decisions. Everyday decisions, like what to eat, how much to eat, when to sleep, how much work you want to do, how much money you want to save, etc., etc. And as in many other scientific areas of research, scientists have made a lot of amazing discoveries in the last couple of decades about this problem. We have pretty good idea as to how the brain makes decisions. But as you can imagine, this is awfully complicated. But don't worry, I'm not going to talk about that today. Instead, I'd like to tell you about something deeper, something more fundamental, and a bit more metaphysical questions. How well do we make decisions? How good are we as decision makers? Because this is a key to smart living. And if you think about it, we are unhappy sometimes because we make bad decisions. And more often than not, we are unhappy because we think other people make bad decisions. Okay? So to understand better why we are not perfect in making decisions, I think we actually have to look at the relationship between genes and the brain. As previous speakers have mentioned, genes are the segments of DNA molecules that includes the instructions to build our entire body, including our brain. And therefore, we can get some insight as to the failures of decision-making that takes place in the brain if you understand this relationship better. And to get some insight as to the relationship between the genes and the brain, I'd like to tell you about this machine, a robot called Curiosity, that the engineers at NASA built a couple of years ago and sent to Mars. NASA engineers and scientists had a mission. They wanted to understand the environment at the Mars. But they cannot go there. It's too far away. So they built the robot and sent it there instead. But there is a problem. Because Mars is so far away, these engineers cannot control these machines directly using joystick, for example. Imagine a scenario where this robot, Curiosity, is driving down the field, and it discovers a cliff. It cannot wait for the stop command to arrive from the Earth. Because if it sends an image to the Earth, it takes about 12 minutes on average to get to the Earth. And then if the scientists at NASA issued a command to stop the robot, it'll take about the same amount of time to come back to the robot. So it'll be too late. The robot will be destroyed if it was waiting for the command. So it needs an ability to make decisions autonomously, i.e., it needs an artificial intelligence. In fact, NASA engineers realized this, and they wrote more than 2.5 lines of computer codes to create an artificial intelligence and installed it in this robot before it's sent to Mars. So what happens here is that engineers have delegated the decision-making capabilities to the robot. And this happens all the time in our lives. We frequently delegate a task, important task, to other people when we ask someone else to do something for you. This is called delegation. However, there are two major problems with delegation. First kind of problem is called moral hazard. And this happens because the person who has the original task is referred to as a principal, gives a request to the agent who has to follow that instruction, but the agent can cheat. I think everyone in this room was a child at some point, and we all know how difficult it is for parents to control their children's behavior. And we also all remember how easy it was for a child to cheat, do something else other than the original instruction they received from the parents. This is a very common problem of moral hazard. And that's because action is uncertain. What the agent is going to do is uncertain to the principal. And it also happens in many companies. CEOs usually want their employees to work hard, but the employees can cheat. There's a moral hazard. Insurance company wants their consumers to be as careful as possible, but once the consumers buys the insurance, they can be less careful. And that is a lot of monetary loss for the insurance company. So that's one problem, moral hazard. The other problem is called adverse selection. And this is the opposite problem. It happens because sometimes the agent follows the instructions from the principal too carefully. And that's, in some cases, not desirable because the agent who receives the instruction or request from the principal almost always has more information, more accurate information about their environment. So sometimes your child may know better about their environment, and in those cases, if they follow your instructions too carefully, blindly, they can actually do harms. And this is true for employee-employer relationship as well. Sometimes employees at the company might come up with really creative ideas, and you have to harvest them rather than just giving them word-by-word instructions. And I want you to imagine, what if the same problems exist between the genes and the brain? Because after all, brains are built based upon the instructions encoded in the genes. Okay? So now I'm going to tell you what kind of problems the brain faces in order to make good decisions and why it has a difficulty. And I'm going to tell you about 3 different problems as an example. So the first problem is that the brain doesn't have an idea as to what's the best. And of course, if you don't know what's the best, you cannot make good decisions. You cannot make rational decisions because rationality, at least by economists, is defined doing the best. But the brain doesn't know what's the best. So how does the brain deal with this? Finding what's the best among engineers and scientists is known as optimization. And when they have a difficult problem of optimization, they have shortcuts. They do something called gradient descent. And it's a very simple procedure. What you do is that you pick 2 options, and then compare which one's better, and then pick the one that's better. And you repeat this as many times as possible. And since gradually you're improving an option that you're considering, you'll get closer and closer to the best solution over time. That's what's called gradient descent. And this is what the brain does. This is how the brain tries to find the best option possible. And in order to do that, brain uses 3 different kinds of baselines. In other words, rather than constantly picking 2 random options, it has a baseline, and then it picks different options, and then wait until you find something that's better than your current baseline. So what kind of baseline does the brain use? One very common baseline that we all use all the time is your past experience. And this is a good baseline because the fact that you're all here today means that you successfully avoided making really bad mistakes in your past. Because if you did, you wouldn't be here. You would have been dead. Okay? So the fact that you're all alive, breathing, listening to my talk means that your past was pretty good. Not only that, your ancestors' past was also really, really good. So, sounds like a pretty good idea. Using your past as a baseline for comparison in order to find the best solutions, like a really good idea. But there is a problem. This does not go all the time. There are cases where this is not a good strategy. When everything's getting worse. The world is constantly fluctuating. And therefore, if you use your past as a baseline and try to find something that's better, when everything's getting worse, that becomes an impossible task. And therefore, you get constantly frustrated for no good reason. Because the brain's goal is not necessarily to make things better for the future, but to find something that's best. Okay? So this is a good heuristic, but sometimes you have to give it up. The second, and I should tell you that the brain is implemented this strategy by using a chemical called dopamine, a chemical shown on the left. And this is a chemical that increases whenever the brain finds something better than the past, and this chemical decreases whenever you find something worse than the past. And this signal is broadcast to the entire brain. It tells you that the brain takes this strategy very seriously. But this is not the only baseline that the brain uses. Another baseline that you often use is called hindsight. Okay? You take an action, see what happens from the action that you select, but after that, in many cases, you also have the opportunity to observe what would have happened had you done something different. And you can use it as a baseline because if the action that you did not take seem to have produced better action, this is what's called hindsight, then when you face the same situation in the future, you can change your mind. You can do something else. And this is what is produced by emotional response called regret. We have regrets a lot because sometimes we realize after the fact that we could have done something better. But just like the first baseline, this strategy is not perfect because there are many cases where we cannot go back to the past and make the same decision again. Often we face unique choices and you have to go beyond that. And in those cases, worrying too much about what you could have done, how you could have done better, is also wasteful and it leads to unnecessary frustration. So that emotional sort of energy is wasted. And in fact, there is it seems to be dedicated system in the brain called orbital frontal cortex, or OFC, that plays a special role in this comparison because somehow if you had an unfortunate situation and lose that piece of the brain, then you may lose the ability to regret entirely, which may be convenient in some cases. There is a third kind of baseline that the brain uses often, and that is to compare what you did with what other people are getting. And this is also very powerful because a lot of us face the same kind of situations together, and to realize that somebody else is doing better than you should be a really useful information because it tells you what you could have done to do better. So just like other two baselines, this is a very useful baseline in most cases, but if you use it too much, also could be bad because sometimes you cannot do what somebody else did. After all, I'm not Einstein, so I cannot make fundamental physical discoveries. Most of you are not as rich as Bill Gates, and therefore your options are not much more limited than what Bill Gates can do. And in those cases, comparing you with someone else is wasteful and leads to unnecessary frustration. So it's not a good strategy in those cases. So the fact that brain uses a baseline to make lots of comparisons in order to find what's best is the best approach that the brains can come up with from using the instructions from the gene. But you have to realize that they're not perfect. Second kind of problem that the brain faces, which is also really challenging, are social problems. In general, decision-making in a social context is much harder because you have to make predictions as to how other people will behave. And that's a very complicated problem. So how does the brain deal with this? It tries to solve this problem by assuming that everything in your life has some human-like qualities. In other words, we tend to treat everything that we encounter as if it's a part of me. And this has many different consequences. And this is why, for example, when we look at a face of a panda, we have an illusion that we can understand the mind of a panda because we assume that pandas are like us. And it saves you time because you don't have to decide as whether pandas are some completely different animal, whether it has a human-like qualities. It works really, really well when we are interacting with other people, which is what we most of the time do. But this sometimes can go too far. For example, when you see a robot that looks like a human, we tend to begin to treat those robots like humans, sometimes forgetting about the problems that our human fellows have. And that's not ideal. There are other problems that the brain has, and the examples that I gave you so far already implies that the solutions that the brain comes up with to deal with all the decision-making problems that we face are multiple. As we don't have one unified solution. We have many different solutions implemented sometimes in different parts of the brain. And this creates the last problem that I wanted to tell you about, and that is the problem of arbitration. To give you an example of what is arbitration, I want you to imagine the following hypothetical problem. Let's imagine that you have an upcoming vacation, and you have an opportunity to visit either London or Paris. Where would you go? How would you decide? And you can try to solve this problem by studying various facts about these two cities by reading books about London and Paris, or by reading wiki pages about London and Paris, and find out visiting which city would be more pleasant. But there are other strategies too. You can bypass all of that and just go to a local travel agency and ask the travel agent as to which city would be more interesting. But what if there are multiple travel agencies? Then you have to choose, you have to decide which travel agency you should go. And this is a meta selection problem. And this kind of problem we face these kinds of problems all the time as well. And unlike the first cases where you have to compare the benefits and costs of different cities, now you have to compare the reputations of different travel agencies, and that's a completely different problem. Fortunately for us, human brain evolution has created a system in the front of our brain that specializes in solving this arbitration problem. And I think that's our hope, because you don't have to worry. There is a system in your brain that evaluates the past successes of different strategies, and that system is designed to guide you to make a good meta selection so that you can use appropriate decision-making strategies when you encounter a different problem. So to sum up, I have two main messages for you. One is that the brain is not the principal. The brain is the agent. It does not create the instructions on its own. It gets the instructions from the gene, which means that it can face additive selection problem. In other words, you may discover facts and information that the brain, the genes, the principal did not know about. And it's up to you to use that information efficiently to make smart decisions. The second one is that we have multiple strategies and learning algorithms in our brain. We're not programmed to work with one simple strategy. Our mind is not unified as you might think. It has many different solutions. And the world is changing constantly. And therefore, you should be flexible, and you should not stuck with one strategy. Thank you for your attention.